we want to look at interpretation of trigonometric graphs. This one we looked at some time past when you were working alone. But now I want us to have that interpretation together. If you encounter any challenges, please ask. Now, looking at this scenario that we have, because when we are looking at, because in grade 10, we are expected to identify trigonometric graphs. That is, we identify trigonometric functions and derive their equations. We must be able to find the equations after identifying them. You will also have to identify key characteristics such as the functions of, say, the period, amplitude, domain, and range, which are basically the four aspects that we are going to look at today. The period of a trigonometric function is how often the graph repeats itself. That is how often the graph repeats itself. So at this stage, in grade 10, the trigonometric function does not change. When we are looking at the sine graph or the sine function, always it has a period of 360. Cosine graph, it has a period of 360 as well. And tangent graph has a period of 180. Now, with this in mind, we are going to look into this example and analyze what we are supposed to do. Right, you are given the graph of f in x and g in x. Which one is our f in x? F in x, it is this graph here. This one which is drawn in black color. And g in x, it is this one which is sketched using a purple color. Now, they are saying the graph of f in x and g in x are sketched below. Determine first the amplitude of f in x and g in x. Now, when we are looking at the amplitude, of f, we are going to start off with the amplitude of f. There is a formula that we use. Take note of that. Amplitude, unfortunately, this is not very clear. When we want to find the amplitude, I am going to use AMP for amplitude. Amplitude, it is the maximum value of y, the maximum value minus the minimum value. This is the minimum value. These are only y values, the y values. Now let us go on. We want to look at the amplitude of f in x. Basing on our graph, f in x, first of all, you identify and say, okay, this is the graph that we're talking about. Now, the maximum, this graph is oscillating between the maximum here, it can attain is here, which is 2, here it is 2. So the maximum is 2. So we are saying maximum, the y maximum is 2. Now, the y value, which is the maximum value it can attain here, is, this one is 2. And the minimum value it can attain, we are looking at on the lower, the minimum value it can take, so it can take a minimum here. Now we see that it is minus 2. It can also attain a minimum here, which is minus 2. So the minimum value that we have here is minus 2. Now, going back to the scenario that we have, once we have identified this, you want to look at the maximum. Now, the amplitude, we say the maximum y value is 2, and then minus the minimum value, which is minus 2, which we got there, all over 2. So negative times negative is positive. So 2 plus 2, it will be 4. 4 over 2. This one is giving us a 2. This is the amplitude of the graph of f. Now, let us go on. Now, we want to analyze the amplitude of G in f. Now, on analyzing the amplitude, we also look at the maximum. The maximum of this graph can be attained here, and this is this is 2, and here that is where. So meaning to say this graph it can attain its maximum at 2. Its minimum is here. Now this one is at 0, and the minimum here it's 0 as well. So we are saying for G, this one, its maximum, what we have noticed here is that it will be 2. And then the minimum, on the minimum, here, you bear with me, minimum is going to be, now the minimum that we have here is 0. That is the minimum y value. Now, with that in mind, we can now go straight. We are saying the maximum is 2 minus, in our small expression, in our small formula, the maximum is 2 minus this negative is for the one that we got here. So it's 2 minus 0 all over 2. So 2 minus 2, 2 over 2. So meaning to say the amplitude there is 1. So that is water under the bridge. So we'll calculate the maximum, we will calculate the amplitude. On the amplitude, it is maximum, the maximum value minus the minimum value divided by 2. Now we want to find the equations of f in x and g in x. Now, when finding the equations of f in x and g in x, always f in x, we realize that this one is a sine graph, sine function. F in x, it must have a, which is the amplitude of sine x, plus the shift, which is plus or minus the shift, which can be positive or negative. Now, from this general formula that we have here, from this general formula, what is it that we need to do? Already, you realize that the amplitude, it is the coefficient of sine x. So since we've got the amplitude for f, which we got here, you just plug in the amplitude here, which is 2. Now, when you want to find, next we are supposed to find the shift if there is any. As the standard sine graph, the graph of sine of f in x always starts at 0. Therefore, they are up and down shifts. Let us look at it. Since it starts at 0, we want to look at this graph. Where does it start? Right, the one for sine, it starts here. It is 0, 0 here. We can take this point and plug it on sine, on our f in x graph. Now, when we substitute because you have f in x, we are saying f in x is equal to a, our a, which is 2, and then we are saying sine, it is sine x plus q. We want to find the value of q, but we notice that this one is passing through which number here? The coordinates, because generally the equation of sine normally passes through 0, 0. You take this one and substitute here, so that on f in x, that is the y value, it will give us a 0. And then you say 2 sine 0, 2 sine 0 plus q. Now, sine 0, what does that give us? Sine 0 is going to be 0. This one is going to be 0 plus q, implying that our q, the value of q is 0. That is the value of q that we've got. So this boils down to the equation of f in x. It will be f in x is equal to 2 sine x. Is that clear? Now let us go on to cosine or on g in x. If we go on g in x, on g in x, this is the graph that we have. Now, first of all, g in x, we got the amplitude. The amplitude that was, the amplitude that we got, you realize that the amplitude that we had there, it is g in x can be written as a cosine x plus q. But remember, on our amplitude, we say the amplitude we calculated here. So the amplitude of this number here, of this function, is 1. So we are actually saying, on this case, we have, let me go back to that. We are saying our amplitude is 1. So meaning to say, we have, this one is going to be 1 cosine x plus q. This will give us g in x. Now let us look, generally, the graph of cosine, it generally starts at 0, 1. It starts at 0, 1. But this one now, it is starting at 0, 2. This one is starting at 0, 2. That is where it casts the y-axis, 0, 2. So you take this one now, you take this one and plug it into this equation in order to find the equation of this trig function. So in the position of y, you put a 2 here. And then in the position of x, you plug in 0. So you say plus q. We want to find the value of q. So this implies that cosine 1 always, cosine 0, what do we get as cosine 0? Normally, cosine 0 will give us, cosine 0 will give us 1. So cosine 0, it will give us a 1 here. So we are saying 2 is equal to 1 plus q. Now, our intention is of finding the value of q. So we transpose this 1 to the other side. So it will be 2 minus 1. So our value of q is Q is 1, implying that when you substitute this one on that equation, it will give us G in X. This will be G in X is equal to amplitude, which is 1 cosine X plus 1. This is cosine X plus 1. This one has been shifted 1 unit upwards. So it's cosine X plus 1. This is what we have. So G in X, the graph, because we have now calculated the graph, G in X is equal to cosine X plus 1. This is how you find those values. Is that clear? Okay. Now let us check and see if we still have something else. Right. That is, now we want to find the domain. We are done with the equations of f in x and g in x. The domain and the range of f in x and g in x. When we are looking at the domain, basically we are looking at the graphs that we have. Let us analyze the graph that we have. The domain of f in x. We are actually saying we are looking at this graph f in x. The domain, they are possible values. These are possible values of x which can be taken up by this function. Now, the possible values, do we have any number that cannot be taken by this function on this one? From minus 360 to 360, we don't. So we are saying our domain, on the domain we have, this is the domain. When we talk of domain, they are x values. So the domain, they are values of x that starts from minus 360. That starts from minus 360 up to where? Up to 360. It starts from minus 360 up to 360. This is the domain. This is how we can find the domain there. Now, this is the domain of f in x. This is the domain of f. Right. Now let us look at the domain of g. Domain of g it is their values of x. This must be an x. Their values of x, when we are looking at g in x, it is this graph. Do we have any values of x that cannot be taken up by this graph? No. So the domain also starts here from minus 360 up to 360. Inclusive. When we put a square bracket, we are saying even these extremes are included there. This is the domain. Now, when we want to look at the range, we start off from x, the range of f. Now, when we are talking of the range, we are talking about the y values. When you talk about the range, these are the y values. Now, when we talk of range, these are the values of y. So, meaning to say, from this graph that we have, where is this graph? We want to look at the range. The range of f. On the range, you are looking at the minimum and the maximum. What is the range? So for f in x, like we did here when we're finding amplitude, we were saying, okay, when finding, once you are able to identify the maximum and the minimum, automatically automatically the range is a matter of application. We are simply saying the maximum is 2 and the minimum is -2. So meaning to say here, our range, it starts from, you start with the minimum. The range starts from -2 to 2. So meaning to say this one is oscillating between -2 and 2. Now we go on to the range of G. Onto the range of G. Range of G in X. Still, when we are dealing with the range, you are finding the values of X. On this range, on the range, you are looking at the Y values. Now we are looking at this graph that has been sketched here. On the range, what is the maximum of Y, or of cosine here? It is 2. What is the minimum? It is 0, implying that the range of G in X starts from 0 to 2 inclusive. It is oscillating between 0 and 2. That is our range. Right. Now let us go on. We said the domain was -360 to 360. Domain of G -360 to 360. The range of F starts from -2 to 2. And the range of G in X starts from 0 to 2. You can write it like this. There is another way that you can also write. This one can also be written as, because in some textbooks you may find that it is written in inequality form. So it starts from 0 to 2. This one and this one are the same. Same applies with here, the range. It starts from -2 to 2. Now here they put less or equal to. Now with this one, you can actually, it's something like this. So we are saying the range, it ranges from -2 to 2. These are the Y values. Now on this one, if you are looking at the domain, these are the values of X which start from -360. They start from -360 to +360. -360 to +360. These are degrees, mind you. Right. And here the domain starts from -360 to 360. Take note. The notation, if you use this one, it's enough. You can use this one or this one. They are all the same, right? Okay. Now we want to look at the period. Now on the period, I will use, let me use this color. Let me use red. Right. On the period of f in x is this one. Like we spelled out to say the period, it is the number of times the period. There's a part where we talked about the period. The period of a trig function is how often the graph repeats itself. Now, how often the graph repeats itself? Now, with that one in mind, we can start from here and say, okay, Now this graph as it is from here, it is still the same. It's not yet repeating up to we go until we get to this point. When we get to this point, you will actually notice that this part here, it is now starting once more. It is this one. It is this part. Now it doesn't matter. Now, this one, it is the repetition of the graph here up to here. Now it repeats. So how often does it repeat itself? So this one is a complete circle. This one is a complete circle. Now when you are looking at the complete circle, it has started from 0 to minus 360. So meaning to say, when you are looking at the period, when you look at the period, now take note, this that I'm explaining now in grade 10, you will see it also in grade 11. The period, it is the maximum value of x where it repeats. So here, not a maximum. So you have taken 0 minus, you are taking this value. It is minus 360. You must be careful when you are taking these. It's 0 degrees. From minus 360 to 0, it repeats. So you are simply saying 0 minus times the minus is a positive. So the period here is going to be 360. 360 degrees. Now we can look at it. Someone could have taken this one, 0 and 360. Now you say 360 minus 0 still boils to the same point. So the period of f in x is 360. Now, this one will continue with us to grade 11, 12. In grade 12, it will be food and drink. You must have a dominion of it. You must understand it clearly, right? Let us look at the period of, we want to look at the period of g in x. Now, g in x, we can also start from here. Okay, let me use the red color. It starts here, and all along here, it is still new. Now, it goes up there. It goes up there. Now, when you look at this part, from this portion that we have here, from here now, the part that we had, this part is starting to be, it is showing up again. So meaning to say, this one is now repeating. So this part up to there, it's a complete revolution. It starts once more up to there, and then it starts once more, and so on and so forth. So when you are looking at the period, just like we did on f in x, we are saying it's 0 minus 360. It gives us the same. Or someone could have taken 0 and 360. 360 minus 0. So it's 360. That is why here you have the period of f in x and cos and g in x. They have the same period of 360, right? Okay. Now we want to look at another example. We've looked at cosine and sine, analyze the graph, analyze its periodicity, and so on and so forth. Now we have another trig function, which is tangent. Now on tangent, the graph of y is equal to a tan x plus q is sketched below. This is the sketched graph that we have. This is the sketched graph that we have. Now, what are they saying? Determine the values of a and q on this one. These types of questions of say determine the values of A and Q, we are starting on them at this level, grade 10. They will continue with us in grade 11 and up until grade 12. So you need to have a very clear understanding. Now let us look at, we want to find the values of A and Q. Now, and hence determine the equation of the graph. So always, like in this case, we are given the graph which is y is equal to a tan, this is a tan x plus q, right? Now from this point, when finding the equation of tangent, the equation of the tangent, calculate the value of q first. It is advisable to find the value of q first, the value of this one. Now, as we look at this one, we are simply saying, okay, for the value of q, this graph that we have, you just take a point. Normally, the tangent graph cuts at 0, 1, but this one is cuts at 0, 0. But this one, it is cutting the y-axis. We are actually saying the y-intercept. The y-intercept, it is cutting at this one, it is 0, negative 1. Right. So we are actually saying you take this point and then you substitute here. You substitute here. So the value of y will be negative 1. A, we don't know, just leave it as it is. And then you say tan 0 plus q. Now you fall back onto your calculator. What is tan 0? Tan 0, what does that give you? Tan 0, tangent 0, this one. Tangent 0, this one will give us a 0. 0 times a is 0. So implying that we have our q is equal to minus 1. You have got the value of q, which is minus 1. Now let's go back. After we have got q is equal to minus 1, we want to find, we go back to our equation, which is y is equal to a. Now we can find the value of a. We are saying tangent x plus q. But because the value of q, you have got it, so it means to say on the value of q, you can now substitute, replace it with a negative 1 here. Right. Now, you also find another point that is on this graph. We've got so many of them, but you take the easiest. The easiest is this one. So you are saying, so we are saying at which point we can take point 45 degrees. This is 45 degrees and 1. These are the coordinates. 45 degrees, 2. So you are actually saying, now, after getting the value of q, you plug it here. This point that you have, what is the y value? The y value here will be 2, and the a will remain, we don't know, it is the one that you want to calculate. Now we are saying tangent, this one is tangent 45, on tan 45. So what have we done here? We have substituted the value of q, we substituted the value of x, which we have from this point, we substituted the value of y here. Now, we are going on to say, we want to simplify this and see what we're going to get. Let us say tangent 45. This one you don't have to guess. You can use your calculator. Tangent 45. What is tangent 45 using our calculator? This tangent 45 will give us a 1. So we are actually saying 2 is equal to 1 times A. This one is going to give us an A minus 1. Now you make A the subject of the formula. So A, you transpose this minus 1 to the other side, so it will be 3. Implying that the graph of the equation of this graph, it is A. What is the value of A? The value of A is 3, which is tangent x minus 1, which is the value of Q. So we have got the equation that we want. Now, this is what we had. A is 3. The equation is y is equal to 3 tangent x minus 1. Let us go back. We want to find, because we are done with this one, the domain and range of the graph. Still on finding the domain. Now on this one, let me erase this part so that what we do here, we create space for ourselves here. Right. Now, you'd remember that when we're talking of the domain, these are the values of x. These are the values of x. Now, on the values of x that we have, so they are starting from 0. That the one that were given. They go up to what number? They go up to 360. Starting from 0 to 360. But do we have any values that cannot be taken by x here? Yes. Which ones are those? These lines of asymptote. But x, it is such that x is different from 90, is not equal to 90. Is that the only one? No. Is different from 90 and must also be different from, x is also different from 270. X must be different from 270. These are lines of asymptote. Take note when we are writing this one, these are not just numbers, they are angles. So don't leave out, we must use the correct notation. So this is the domain. Let us go on to the range. On the range, we want to find the values of, when we are talking of the range, do we have any numbers here? Let me go back to it. On the range, with your permission, let me erase this part also. Now, on the range, we want to find the values of x, the values of y. Do we have any values of y? Do we have any values of y that cannot be taken up by this graph when we are analyzing? Do we have any? No. So meaning to say the range is all values of y real. We have no restriction, we have no limitation there. Is that clear? Now let us go on. The domain is 0 degrees up to 360, and x must be different from 0 or 207. So these ones are the lines of some asymptote. They must be different from these. Because if we just spell it out and leave it here, these numbers are within. So we must spell them out. So the range, they are all values of y real. Now, we want to find the period of tangent. Now, on the period of tangent, we want to look at it the same way we did the other one. Now, we are saying, on the period of tangent, this graph will go and it will go closer and closer to the line of asymptote, but will never come into contact with this line. It will be drawing nearer and nearer. Like you can have here, it may go nearer and nearer and nearer, but not coming into contact. Now, when we look at this one, you are saying, how often is this one repeating itself? Now, we can start from here. This one is at 90, and this one is at 90. Because now, so meaning to say, on our period, on the period that we have, the period, that is the period will be, now when you look at this number here, it is repeating itself, let us say, on the period that will give us, if we look at this number, that is 270, this is the number that it repeats from 90 to 270. So you say minus this number, which is the line of asymptote here, which is 90. Now, you are simply saying 270 minus 90, what did you get? 270 minus 90, this one will give us 180. So the period is 180 degrees. Always the period of tangent is 180. And the period of cosine and sine is 180, which is the one that we started off with. Period of tangent, 180. Period of cosine, 360. Period of sine, 360. This one you must have an understanding of it. Now, with this that we have, we've come to an end of our today's lesson. Now, if you encounter any challenges, please ask. There are some who are not asking, some are doing well, they are asking, and then I'm clarifying issues. Because if you don't ask, it means to say things that you don't understand will be piling. Please ask. Now, I would want you to attempt to complete exercise 14 on page 306. This one, try it, work on it, and mix the exercises on page 307 to 3, all of them, because this you are working on this one over a weekend. Now, if you get answers that are different from the ones that are given there, please ask, and I will clarify. Have a good day. Thank you so much.